Hi, I'm Rebecca. I've been working with Cissie and Jefferson on this benchmarking project, benchmarking the DAOS storage system on Aurora as like a normal user to see how it performs under those conditions. And we wanted to give a brief summary of some of the benchmarks we've run so far, and then some interesting errors they want me to share. So we were using three tools to benchmark FIO, IOR, and MD test, and then the IO 500 suite of IOR and MD tests, and using both the POSIX API and the DFS API on a diffuse mount point. And then at the end, I will show some errors. But already, thank you very much to the people who may have already dealt with my support tickets about them. But for context, our pool has fluctuated very slightly, but it's usually 4,064 targets, and we had 3 terabytes or around 3 terabytes of SCM storage usually, and then 97 terabyte for NVMe. So the first benchmarks we were running were for FIO, and using the PBSync IO engine on the diffuse mounted POSIX container, we were looking at performance across 4 parameters. For the access type, we looked at reading only, read heavy job, reading and writing in a balanced way, write heavy job, and writing only, and all of those for either random or sequential access patterns. And then we looked at block sizes across 4K, 16K, 1 megabyte, 2 megabyte, 4 megabyte, and various IO depths and number of jobs, where IO depth would be the number of IO units to keep in flight, and the number of jobs is number of clones of the job. And this was for one single client to access our whole pool. So we found that there was not a large difference between the random and sequential accesses performance. And then as the block size increased, we got higher bandwidths with that. And there was some saturation, as you can see, after like 1 megabyte or 2 megabyte we reached. And the write bandwidth for using this POSIX API on the diffuse mount point was much higher than the read bandwidth, although these numbers overall, they will be much lower than when we look at what we saw for the native DAOS API later. And for different numbers of jobs and IO depths, we didn't really see any significant trend with regard to them. And then for our IOR benchmarks, we were using a variety of number of nodes using the DFS API on a POSIX container mounted for diffuse. We were keeping a block size of 128 megabytes and 32 segments so that we had 4 gigabytes per rank of data. And then we varied the transfer size and the number of ranks per node, and we looked at both reading and writing bandwidths. So we saw that read and write bandwidth increased with increasing tasks, saturating about 32 tasks when we look at what was, say, maybe medium transfer size of like 2 megabytes and similar sizes. And then with larger number of MPI tests per node, yeah, we saw the higher bandwidth. And so our top graphs there are with 2 megabytes transfer size, and the lower graphs are for 16 megabytes. But we had tested other ones. These ones just were maybe some representative examples. And we noticed that as the transfer size gets larger to some sufficient size, like 16 megabytes, there was some adverse effect once you reach a certain number of tasks being run per node, and all the read bandwidth suddenly would get much lower.
True.
And then for a single client using the DFS API, we found that although the read and write bandwidths were much more similar to the than they were with the POSIX API, the read bandwidth was typically slightly higher. And for the latency, we found that it scales. There's not as much a dramatic change in read latency as there's for write latency. But there is some interesting change where as the number of nodes increases, write latency starts to increase faster than the read latency at lower number of nodes, even though 32 nodes becomes higher for everyone. And then using the IO500 benchmarks, we ran a variety of IOR and MD test benchmarks, and we saw here the 8-node result. We saw the DFS API achieved about 5 times higher bandwidths and something around 190 times higher IOPS than POSIX on the diffuse mount. And then for some interesting errors we had, there was this one I will look more into after the maintenance, but when we were running the MD test, the job seemed to be maybe some sort of unbalanced and filling up the storage space faster than we expected, where a small number of targets failed to empty after the container is deleted. So in the winter or February, we were running IO500 tests, and we saw that this, for example, this command succeeded with 1 million files and file size of 3,901. And then more recently in, I believe, March, the MD test commands that we were trying to run with one order of magnitude less files, 100,000 files. We could run 10,000 and then we would go up to 100,000 and it would fail. And we were trying with both the file size of 6,144 or 1,024, but I increased to 6,144 because maybe it was all too much to fit into our the tier 0 storage. So I tried to get above the data threshold, although I can't really verify what that is as a user. So we thought like this client node, which we were using 48 cores, we've been using 48 cores also for the IOR and the IO500 and MD tests. And then for 48 cores, creating 100,000 files per process, which were here 6 kilobytes big, would mean only 27.5 gigabytes for just the files data. So there should be plenty of space somewhere. So maybe something became imbalanced and it was filling up something faster than the other. But at the end of that job, it would have, I would delete the container and it would have an average of basically everything is empty except for the minimum. Someone is full, so the pool cannot be used because there's something still full. And then when we were first starting, we had some errors with FIO, which are kind of mysterious. I'm not sure why, but even without attempting to set the number of CPU cores to bind to,
No.
whether it was as the FIO's option or using pass set or not at all requesting some list of cores, it would give clock set affinity failed invalid argument errors. But we're still not sure why that happened, although it's the results are what I showed earlier. And then briefly in February, there were some errors for when doing IOR reading and writing tests that just happened randomly. It doesn't seem to have a pattern with what test exactly was being run, but they would show the NA host unreached error, and the data the data we got out seems okay. It seems typical to the rest of the data, because this one was retrying. Um, so we're not sure why that happened either, but it was interesting to see. And then another thing that we don't really see anything on our end, but in something in October, there was something about our pool that caused increased message flow reporting alerts, and that could, at that point, was just fixed by destroying the pool and recreating it. And that was only on the admin side. But that's all I have for a brief summary of what we were doing.
Thanks, Rebecca. Any questions for Rebecca? And Rebecca, these are all results reported running on Aurora, is that correct?
Yes, these were all on our pool Itusar on Aurora.
Thanks. I can't wait for your tickets. Lots of
Thank you
things to
so much
debug.
for all your help.